Hello everyone, in this video we'll be solving problem 145 binary tree post order traversal. The problem statement is given the root of a binary tree, we need to return the post order traversal of its nodes value. The way post order traversal works is if a parent node have both left and right nodes, we start with the left node first, followed by the right and then the parent. This is the sequence we need to follow when we are iterating using post order traversal. If you look at example number 1 and apply the same rule, node 1 does not have a left leg. So we'll start with the right leg. Right leg has a left leg. So we'll start with 3. Then we'll go to its parent, which is 2. And after 2, we'll go to its parent, which is 1. This is the output, which matches the expected value. Let's use this principle and apply it to example number 2 and compare the output. Start with the root node 1. We'll go to its left. 2 also have a left, we'll go to its left leg. 4 is the leaf node as it doesn't have any legs, so we'll write 4. Then go to its parent's left leg, which is 5. 5 does have a left leg, so we'll go to 6. Write 6 at the output as it is a leaf node. Then we'll move up and go to 5's right node, which is 7. Then we'll write the 5. We'll go to its parent, which is 2. After 2, we'll go to 1's right side, which is 3. 3 doesn't have a left, so we'll go to its right then. 8 does have a left leg, so we'll write 9. There is no right leg for 8, so we'll write 8 then. After 8, we'll go to its parent, which is 3. And after 3, we'll write 1. This is what the expected output should look like. With this solution, the time complexity is O of n, where n is the number of nodes in the binary tree, and the space complexity is O of n, as we are building this collection to return the output. I hope you were able to understand this explanation and how post-order traversal works. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing the results array where we'll store all of the node values as we are traversing. I then call the process method, which I'm using as a helper to iterate recursively. I'm passing the node and the results variable. The first check within the method is to verify if the node is not null. After confirming the node is not null, I'm calling the process method again and passing the left leg of the node. After left leg is processed, I'm then calling the same method, passing the right leg, and at the end, I'm processing the parent node itself. So basically, I'm writing the left leg first, followed by the right, and then the parent node itself. After this recursive traversal is complete, I will have all of the outputs saved in the results variable, which I'm returning at the end. Thank you for watching this video. I hope you were able to understand this explanation and the source code. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.